Hi, my name is Hanaan Abdulle. I'm a senior at Highland High School, and my project is a photometric transit analysis of WASP-33b. To start off, this project is not a confirmation, but rather a characterization of the exoplanet and its host star. To start off, the host star is a bit unique as it is the first host star to be a delta Scuti variable type star, which just means that it pulsates but pulsates irregularly or non-sinusoidally. Um, More about the host star, it is oblate at its pole due to its high rotational speed. And due to its uniqueness, early astronomers considered this star system a candidate for star-planet interactions. And so through this study, I will determine whether or not the star is interacting with the exoplanet, and that would show up with the velocity of the exoplanet accelerating or decelerating by the star adding or removing mass from the planet. And also, in regards to timing, the orbital period would change. So it'd either take longer to go around or it would go around faster. So my question is whether or not the orbital period of WASP-33b is constant or not. My hypothesis is that since the star is oblate with the high radial velocity, I would think that the star will interact with the exoplanet, and that will be through altering its orbital period. For my procedure, I had three parts. The initial part is data collection, and I did this through the use of my mentor's observatory, the Lost Gold Observatory, and I calibrated the telescope, which was an automatic telescope, the CCD camera, we use a photo V filter, and locked the telescope onto the star, and then adjusted the camera calibrations after meridian flip. The bulk of the project was, or the data was for astrophotometry, and the program that I used was Exotic, which is the Exoplanet Transit Interpretation Code, which is funded by NASA. And it is very useful because it kind of does everything from data reduction to then light curve fitting. So it starts off with you provide the raw data, bias, dark, and flat frames, and it creates the scientific images, aligns the images, and then conducts the astrophotometry. Um, and it then gives you the light curve fitting and the final planetary parameters for that night of transit. The last piece is the graphical analysis, and that is where the 10-year transit analysis um, is done. And this is through collecting the mid-transit times of each of the previously published nights of transit, and as well as the two new nights that I collected, and conducting an observed minus calculated um, graph. So the first night's data, which was December 8th, 2020, compared to the second night, December 20th, 2020, we can observe that both the light curve fittings are pretty similar. And the residuals, however, are pretty different, and that can be accounted for by the star's pulsations, as since it pulsates irregularly, each night's residuals will look pretty different. And then for the first graph, that is the observed minus calculated using the initial orbital period. And as you can see, the slope is a lot larger than zero, as And what this tells us is that the observed orbital period and the calculated orbital period are not the same, or as close as they could be, because the slope is the difference between the observed minus calculated, um, the observed and the calculated orbital period. I then calculated a new orbital period through the use of the slope of the original graph, and was able to get a more precise orbital period of 1.2198749 with an uncertainty of minutes, and that the orbital period is measured in days. So the final planetary parameters for each night were consistent by a margin of their uncertainty. So I could conclude that both nights were the data of both nights were collected and processed correctly, and my margin of difference between my observed minus calculated for my night's observation matched previous differences by other research, so my difference would be standard. To conclude, there is no evidence to suggest that over a 10-year time period that the exoplanet, the star-planet system are interacting, as there is no change in orbital period, which means there is this host star is neither accelerating or decelerating by by changing the exoplanet's mass. I was also able to calculate a more accurate orbital period, and I concluded that regardless of the oblateness and high rotational velocity of the host star, there is negligible effects on the planet. I can further conclude that the star-planet interactions are minimal, as the star has not affected the planet's orbit measurably over a 10-year time period. And that is my research. Thank you.